Hey guys, I know that those of you that were here Monday, you were here for the ratio test lesson, but those of you that were not here, I wanted you guys to have some notes to follow along with. So I'm going to do the same examples that I did on Monday, but this way you guys have a video that you can go back and watch as many times as you need to. So the ratio test is for scenarios such as a series that has any combination of a geometric portion, but primarily for factorial. So something like that, where you can't definitively say, that the numerator is approaching infinity any faster than the denominator. So nth term test is really not conclusive because you don't really know what's happening to that limit. But particularly anytime you have factorials, always use ratio test. If you have some portions that are geometric along with, another type of function, such as a rational function, then you definitely want to use the ratio test as well. So the ratio test says, assume that P equals the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n exists. So this is another test that uses a limit. It uses it in a slightly different way than the limit comparison test uses it. You are actually using the same series. You're just using the n plus 1 term of the series to compare it to the nth term. And so it has three outcomes just like limit comparison does, but the outcomes are a little bit different. And so it's very easy to get limit comparison and ratio mixed up. So you just have to be careful about that. But if the limit exists, very much like limit comparison, you have three options. So A, if P is less than 1, then the series converges absolutely. Now, we'll talk more about absolute and what we call conditional convergence later. That'll be tomorrow's lesson or Thursday's lesson. And so we'll get into more about what that means. But the ratio test is a test that you can use to test for absolute convergence. There's other ways we can test that, but this is one of them. And it is because you have the absolute value there. And so we'll talk about how that changes things. Ratio test is also what you use for what we call power series, which we'll get into next week. So second option is if P is greater than 1, then the series diverges. Okay. And then the third option, if P equals 1, the test is inconclusive. So at that point, you would go and find another test to see if it converges or diverges. All right, so that is the gist of what the ratio test is. So now I'm going to do a few examples. All right, so example 1. Does the series, the infinite series, never mind, take that off. Don't need two of those. 2 to the nth over n factorial. So very similar to that first kind of format that I wrote. Converge. Okay, so we would just start off by setting up our limit. So the limit as n approaches infinity. So the a sub n plus 1 term would be 2 to the n plus 1 over n plus 1 factorial divided by 2 to the n over n factorial. Okay, now you can go ahead and write that as multiplying by the reciprocal, but I just wanted you to see that on the first example. So we would definitely want to fix that, make it a little bit easier to look at. So it would be times n factorial over 2 to the n. Now, at this point, we really don't need absolute value anymore because we know that n goes from 1 to, or goes from 1 to infinity. So we know it's not going to be a negative number, and even if we plugged an in, no portion of that's going to be negative. But what you want to do at this point is you want to eliminate things, simplify it so that you can evaluate the limit from n to infinity. So remember that this right here, 2 to the n plus 1, is the same as 2 to the n times 2 to the 1. So if that's what I really have right here, then I can cancel out these 2 to the n's. All right, so those are gone. And all I have left is 2. Well, n factorial can be expanded out because n factorial is really n times n minus 1 times n minus 2, so forth and so on, because you're multiplying by one less value until you get to 0. So n plus 1 factorial, okay, right here, that can also be written in expanded form. So that's n plus 1. If I subtract 1 from that, I get n, and then I continue subtracting 1. So if you notice, after this first n plus 1 term right here, I begin to get these terms right here that are actually equivalent to this up here, okay? So that means that this all cancels out, and you don't have n factorial anymore. And so what you have left at this point is you have this 2 to the 1, and you have this n plus 1. And so you have the limit, as n approaches infinity, of 2 over n plus 1. And as n approaches infinity, that is going to be 0. So according to our outcomes, if p is less than 1, then the series converges absolutely. So we would say, the series 2 to the n over n factorial converges absolutely according to the ratio test because p is 0, which is less than 1. And so we would write that out. So that's the gist of the ratio test. I'm going to stop there just so this video doesn't get super long. Obviously, it can have various outcomes, but that is the general idea. You're looking to set up your limit and see what you can simplify and cancel, evaluate the limit, and then interpret what that means. So hope this is helpful.